Alright, students, in this video we're going to talk about derivatives, and before we do that, we need to talk about slope. So again, slope is the change in the y and the change in the x, or you might have remembered it as a rise and run. And so basically, if you start from this point and go to this point, you go rise here and then run across this way, or you can go down this way and then across backwards. Either way, as rise and run. Now, why is that so important? Well, because rise and run, yeah, that doesn't seem too important, but if this was time and this was distance, you would now have distance divided by time, and that would be velocity. This could be your money over time, if we're talking about the stock market or your bank account and stuff, and that would be your change in your money over time, and you'd hope that that was going upwards instead of downwards. So if we talk about slopes, we can be talking about your increase in your money, increase in the economy, increases in cases of viruses spreading, as is currently the case. And so all those things, velocities and slopes, are definitely relative for what we're doing now. Okay. Now the question comes up, how do you find the slope for a curve like a parabola? Well, the answer is you need another trick. Because slope, when we saw it, was based on straight lines. What we have here is we have something curving. Okay, so what we're going to do is, to find slope, we need 2 points. So we're going to choose 2 points. All right, and if we connect those 2 points, we could calculate the slope by doing rise and run. Okay, by connecting there, rise, and there, the run. Okay, now, is that the actual slope of the tangent line? No. So what we're trying to do here is the derivative is the slope of a tangent line, and the tangent line should only cross at a single point. Well, we need 2 points for slope. So we use 2 points, but what we're going to try and do with the derivative is get those points closer and closer and closer and closer. Now, unfortunately, you can't really see our little line here, but imagine a line sliding through there with an equation like that, a straight line going through there. That's what we would have. So let's back that up a step. There it is. That's the slope. That's the approximate change from this point to this point. But that cuts out a lot of the curve. If we wanted more exact, we need to get these closer and closer and closer. All right. And the next video will go through then how we go from there to the actual formal equation of the derivative. And the definition of derivative, if you go on Wikipedia, is right here. And again, it looks really bad. Don't worry about it. The next video, in less than 10 minutes, we'll go through all of this and show you how we got from slope into this crazy notation. The only tough part about this is it looks bad because there's no numbers. But most of these will be plugged in with numbers, and the whole thing then simplifies itself down. And don't worry, you have a whole semester of calculus to start understanding that. This video, again, was just the introduction. So again, thanks for watching, and I'll see you next time.